Stoneywood Paper Mill is a fine paper mill located on the banks of the River Don in Aberdeen, Scotland. This is one of Scotland's salmon fishing rivers, so the need to respect the environment is vital. The water from this river is used to manufacture paper and also enables steam and power generation. Very little treatment is needed to clean the water. Stoneywood Mill was founded in 1770 when the original owner installed one of the first 4 Rejoignez-nous paper machines in Scotland. Many of the buildings are over 100 years old. The mill was later acquired by Wiggins-Teep in 1922. Wiggins-Teep subsequently merged with the French paper company Arjowiggins in 1990 to form the present company Arjowiggins. Incoming paper pulp is bought from central sources and is manufactured by various pulp mills throughout the world. Hardwood, softwood, eucalyptus, recycled pulps, bamboo pulps and mixed hardwoods are used in the production of fine papers. All major pulps used on site are FSC accredited. Hardwood and softwood are loaded into the pulper. This travels on conveyors to the pulper, where approximately 21,000 litres is used to pulp the wood into a liquid, with the help of sharp rotating agitators turning at high speed for 10 to 12 minutes. Once pulped to the correct consistency of approximately 4 to 6%, the mix is sent to the stock holding tower for the next stage of the paper making process. The hardwood and softwood are kept separate at this point in order to treat each pulp type correctly later on in the process. The next stage is to refine the pulps through a complex arrangement of pipeworks and very fast-moving cutting discs. Refining promotes sheet strength, better tear strength, fold, and better sheet formation. Color control and matching of shade is very precise in paper manufacturing and is controlled by a complex closed-loop computer control system. Large containers full of dye are supplied by external suppliers in concentrated form. These are then diluted and added in ratios to achieve the dye match. The normal balance of colors used for most shades would be a blue-yellow-red mix, although some optical brightening agents, OBAs, may be used. Centrifugal cleaning is used to clean any small particles of dirt from the stock solution, and screens can also be used to filter out larger contaminants such as sticks or knots of pulp. The blending process is where hardwood, softwood and reusable process waste called broke are blended together. The normal ratio for fine paper would be to have 80 to 20% hardwood to softwood mixed together and then mix in a ratio of broke. PMH shown here is designed to run at 200 to 500 meters per minute, with the average speed for watermarking at around 325 meters per minute. Next, at the headbox stage, the stock is diluted down to 1% consistency and fired at high speed onto a rotating wire, which is a continuous woven nylon fabric specially designed to form paper. The wire is then passed on dewatering foils and then a vacuum is used to remove as much water as possible. The breast roll shakes the wire over the foils to remove any excess water. This process also helps sheet formation. The paper, which is still mostly wet, is then processed through the dandy roll, which will press the paper to get rid of excess water, as well as watermark the paper. Watermarks are usually negatively imprinted into the sheet and can be set to position the logo in a precise area of the sheet. Pressing is achieved with heavy rubber-covered rolls applying weight and hydraulic pressure to the sheet of paper as it travels along the machine. Water is extracted by continuous woven cloth felts, which carry the water away. The sheet leaves the press section at 45% solid and is now ready for steam drying. There are a number of drying sections in a paper machine. The number of steam-filled steel cylinders in the drying section varies from machine to machine. On PM8, each section is heated progressively to 136 degrees centigrade to dry the final sheet to an average of 5% moisture. The final curl of the resulting paper can be manipulated to achieve flat or near-flat paper. The size press is an essential part of the paper-making process. Sizing operations are carried out primarily to provide paper resistance to penetration by aqueous solutions and generally improves printability. The treatment also provides better surface characteristics and improves certain physical properties of the paper sheet. Surface sizing typically uses starch particles to fill the surface voids in the sheet. After sizing, the paper is dried by evaporation once again. This drying session is much shorter than the first. At this stage, the flatness of the paper is perfected. This is the main control room of a typical paper machine. Paper makers spend millions of euros on process control, with complex computers controlling weight, moisture, color formation and drying control. There are usually 3 or 4 operators for the complete process of making paper, and one man, the paper technician, is responsible for everything in this room. The next stage is calendering. The calendar rolls are highly polished heated tungsten carbide coated rolls, which make the paper as smooth as the customer requires. The scanning head of the quality control computer passes over the sheet of paper as it runs down the machine. Inside this head are a number of different instruments which continuously measure and send feedback to the main QCS computer, which in turn makes control adjustments in order to maintain paper qualities. At the next stage, the paper is wound into reels and is now ready for cutting and other conversion processes. The reels can be anywhere from 4 to 6 tons in weight. Once complete, the reel is broken out and a new reel is started, all in a continuous process. Reels are temporarily stored in a holding area ready for inspection and cutting. The reels are next loaded onto the cutter back stands, either individually or several at a time for inspection. Once loaded, a series of video cameras views the paper for holes and dirt. Any defects are rejected later on via a computer-controlled process. The paper then goes through a series of cutters, first to cut the paper in the machine direction, and next through a series of circular knives to slit the sheet to the final customer width, ensuring clean and precise edges. The paper is then cut across the width using full-width cross-machine blades mounted on rolls on both sides of the sheet. Sheets are next stacked using vibration plates and conveyors and are now ready for ream wrapping. The stacks of paper are transferred via conveyor to the wrapping section. At this stage, a wrapper is passed onto the paper and around the belly of the paper. The wrapper is cut and then glued with hot glue. A robot applies labels to the reams of paper as they travel along the wrapping section. Each label contains an order number, the date and time of wrapping, barcode data, and all product data needed for stock control and by the customer. The reams of paper are then automatically stacked and passed to a computer-controlled gas-fired shrink-wrap oven. The pallet shown is a complete pallet of 120-gram Conqueror. Once finished, the pallets are transported to the dispatch warehouse. Each manufacturing run is timed to coincide with a container delivery. A planning department works to ensure that various orders arrive on time at the dispatch warehouse for shipment. A department of stock controllers then arrange shipments via road, rail, and sea to various parts of Europe, the Middle East or further afield such as China or South America. Pallet packaging includes top boards, edge protection, moisture protection, etc. to prevent potential transport damage. Stoneywood paper mill, like every Arjowiggins mill, has a duty to care for the environment. Through its state-of-the-art effluent plant, the mill monitors and controls turbidity, suspended solids, pH, coloration and biological oxygen levels to the extent that wildlife such as ducks can be present in the mill. The paper-making process consists of several different stages, as can be seen in the following diagram.